Tool setting and high-speed broken tool detection cycles are available for many popular machine controllers. Details are available from your Renishaw supplier. The software is supplied on a CD with the installation and user guide, along with an easy-to-use programming guide. Use a tool of known length and diameter in conjunction with the alignment cycle. With a dial test indicator mounted on the machine table, jog the spindle nose in the Z-axis to make contact with the dial test indicator. Make a note of the machine position and dial test indicator reading. Now load the comparator or tool of known length and diameter into the spindle and jog it in the Z-axis to make contact with the dial test indicator. The difference in Z position equals the tool length. This value should be recorded. The laser position relative to the spindle is inputted to the CNC controller. Renishaw non-contact software cycles include alignment and calibration cycles to align the laser to the spindle axis. Use the alignment cycle to optimize the setup of the system. Optimizing the setup creates the ideal operating conditions for the unit. Slacken the X and Y locking screws. Align the fixed unit to the XY axis by hand. Carefully tighten the X and Y axis locking screws, taking care not to move the unit. Use a tool of known length in conjunction with the alignment cycle to align the unit in the Z-axis. It must be parallel to the machine table to align the laser to the spindle axis. Slacken the Z-axis locking screw. Adjust the Z-axis adjusting screw. Check the beam alignment. This can be an iterative process. Carefully tighten the Z-axis locking screw, taking care not to move the NC4 fixed unit. After aligning the system, run the alignment macro again to check that the adjustments have aligned the NC4 within the required specification. The system is now ready for calibration.